Hi, good morning and good afternoon, everyone. Thank you so much for joining us. My name's Ilana Rennert. I help manage outbound marketing for SanDisk, and very excited to have a full team with us today to talk about all-flash software-defined storage and when great speed comes with great efficiency. We have a great panel with us from IDC, Nexenta, Northern Backup, and SanDisk. We love to have your questions as well, so anytime throughout the presentation, if a question comes up, please submit them and we'll be happy to answer them later on within the presentation. So let's go ahead and get started. Legal, always have to have the forward-looking statement, so anything we say, just take it with a grain of salt as always. And for the speakers, there I am, I'll be moderating, but also I'd like to take a moment for everyone to introduce themselves. So Steve, say hello to everyone.
Hi, good morning, good afternoon. Thanks, Ilona. I'm Steve Wilkins, and I'm responsible for the InfiniFlash all-flash array that's a key building block for all-flash software-defined storage here at SanDisk.
Thank you. And Mike?
Hi, everybody. So I'm Mike Letchin. I'm the field CTO with Nexenta. So I play a bit of a hybrid role between our product side and our sales and marketing and our field team, and have worked with a lot of guys on the call as we present some of these great SDS solutions out for some of the all-flash needs.
Fantastic. Thank you. And Brent, say hello.
Hi, everybody. My name is Brent Thumlert. I'm a systems architect with Northern Backup. I look after our managed services architecture, capacity planning, and we've been an Nexenta customer for about 18 months now.
Great. And last but certainly not least, Eric.
Thanks, Ilana. Hi, everyone. I'm Eric Bergener. I'm a research director in the enterprise storage practice at IDC, and I focus on all-flash and software-defined storage.
Great. Thank you, everyone. And Eric, please go ahead and take it away.
Okay. Thanks, Ilana. So what I wanted to do today is to make some preliminary comments, sort of to set the stage about what's happening with Flash as it's starting to penetrate the enterprise storage market. So why don't we start off with taking a look at what's happening at the market overall. So if we look at the overall external enterprise storage market, we can see in 2015 that's about a $26 billion market. And that's not going to be growing very quickly. By 2020, it's only going to be about $26.3 billion. But what you can see from this slide is that all flash configurations shown by that gray box that's at the top of the chart here is going to be growing extremely rapidly. In fact, at about a 21.4% compound annual growth rate over the next 5 years, should be almost an $8 billion market by 2020. Now, that's clearly growing faster than the hybrid flash array market, and you can also see the sort of legacy all HDD-based space, hard disk drive, is actually shrinking over that time frame at a pretty rapid rate. So clearly, people like flash. They're deploying it more and more, and they're deploying it also for more and more workloads. So it clearly is not just being bought for a single siloed kind of an application environment, which was the deployment model when things started back in the 2011-2012 timeframe. People often would buy all flash for, let's say, an Oracle application or a VDI application. But what has clearly happened is people like what they get from a performance point of view, and they want to move more workloads to flash over time. So that's what's driving the penetration of flash in these markets. Now let's take a little bit closer look at the drivers. So everyone is very well aware of the performance aspects of flash. Much better latency than hard disk drives, much more consistent performance, even in the face of varying workloads, higher bandwidth, higher throughput. So that's typically the number one reason people want flash in their environments. But there are also some other reasons that people buy flash. So one of the other areas is that they want to move to a more efficient storage infrastructure. With flash, you need far fewer devices, so you need a lot less floor space. and you use less power and cooling in those environments as well. In fact, one of the things that we often hear from customers when they've moved from legacy architectures to all flash is they might move from a situation where they actually need 2 or 3 racks filled with hard disk drives to a configuration that might only need, less than half a rack when they have flash. That's because each flash drive brings such performance with it compared to what you get out of hard disk drives in terms of IOPS that you can really reduce the device count between 60 and 90%. So this is a huge savings. Now, obviously, you also have to think about capacity, and you need to add back in some additional SSDs in most cases to sort of fulfill the capacity needs. But from an IOPS point of view, you end up not needing very many drives. Now, it's also interesting that as you add SSDs back in for capacity, you get to do that at a discount because of the data reduction ratios that you get out of flash. And we'll talk a little bit about that a little bit later. And then one of the other key reasons we see people moving to flash is it just simplifies their environments significantly. This is due to a number of reasons. One of the key ones is that performance problems, in the time that your staff spends dealing with phone calls from end users about performance complaints and trying to tune the storage to fix those all immediately go away once you move to flash, because flash literally has performance to burn in these environments. And many of the systems designed around flash are really bringing a new way of expanding systems, allowing you to expand capacity and or performance in these environments non-disruptively without impacting application services. So there are some new models there that are significantly better than what you may be used to if you're still running legacy, kind of legacy storage architectures that have been available over the course of the last 10 years. So I wanted to just bring out a couple of data points about all-flash from the research and the time we spent talking to end users about their use of this technology. So one key point, sort of getting to market penetration, is that basically all of the different ways that you can buy storage solutions, storage appliances, software only, hyper-converged, in converged environments, things like FlexPod and things of that nature, you can pretty much get all-flash configurations in every one of those. So that's kind of an important indication of the importance of flash in these environments. Now, we did a survey last year. This was under some custom work that we did, and we were asking people about their deployment models and patterns for flash. And one of the interesting data points that came out of that research was that fully 80% of the organizations that were respondents on the survey had already basically committed to an all-flash for primary storage strategy over the long term. That didn't necessarily mean they were deploying all-flash today in these environments, but it did mean that they had flash deployed, they were comfortable enough with it that they wanted to move more and more workloads to it as they started retiring some of their legacy equipment. And this is a significant change from what we saw when we did a similar survey back in the early part of 2014, where at that point there were only about 10% of organizations had said that, yeah, they thought they would be deploying an all-flash for primary storage strategy going forward. And again, I just want to point out that, we're talking about primary storage here, not secondary storage environments. So primary are latency sensitive, mission critical, typically drive direct bottom line business benefits, and some of the secondary areas are things more like backup, archive, DR. People weren't thinking about necessarily using flash for those types of environments, and that's primarily driven by cost considerations. Speaking of cost, so we can take a quick look here at what's happening with SSD versus HDD costs going forward. One of the key, in fact, I would say probably the single biggest reason people give for not deploying flash is cost. And costs are continuing to plummet on SSDs. So this chart here shows a blended enterprise SSD dollar per gigabyte cost. So this is across a variety of SSDs in different capacities targeted for use in enterprises versus what you'd be paying for 15K RPM hard disks in that same time frame. So you can see by next year, for a raw dollar per gigabyte cost, flash is a little less than twice the cost of hard disks. And when you take into account the data reduction ratios, that means that if you only get a 2-to-1 data reduction ratio, which is actually quite low based on what we're seeing in the installed bases of most all-flash configurations out there today, you would be at a lower effective cost than you would be for HDDs. And in fact, what we see with a lot of the all-flash configurations, if you do take the data reduction ratios into account, people are already paying, in many cases, less than $1 for an effective dollar per gigabyte cost for all-flash configurations. Now, just a word on data reduction. Those ratios clearly vary by workloads. Database environments, you're typically not going to see data reduction ratios that are much greater than 2-to-1 and can certainly be lower than that. Mixed virtual workloads, server consolidation, home directories, those kind of workloads, typically we'll see between 4-to-1 and 6-to-1 data reduction ratios in those kind of mixed environments. And then clone-intensive environments like virtual desktop infrastructure and even test dev, which is starting to appear on all-flash as sort of a secondary workload, we'll see much higher data reduction ratios there in the, often as great as 8-to-1 or 10-to-1. So, that should give people some food for thought on thinking that flash is expensive. So the final point I wanted to make is that our forecasts are basically based on our assumption, based on what we're seeing with uptake of flash, that by 2020, all flash configurations will be driving over 70% of all the primary storage revenue. And so this is really a clear indication that all flash is taking over in primary storage. It's not taking over in the secondary markets, but it clearly is going to be driving more revenue even than the hybrid disk configurations and certainly than the sort of legacy HDD-based configurations that are out there. So I wanted to just mention a couple of additional storage trends that are related to flash deployments. So in the software-defined storage area, this is a market that's already quite large, about $4.5 billion this year. That's going to be growing to over $9 billion in 2019. And what we're seeing people do here is really try to leverage the web scale economics, the flexibility of these environments, and the ease of management that you get from these types of configurations. And these configurations, what we're referring to here, are basically x86 servers running internal storage, which could be all flash, it could be hybrid flash, and then combined with a software layer that can provide block, file, and or object-based access in these environments. So we're seeing these get used more and more. They today are sparingly used for primary environments, but we clearly are seeing people deploy in those types of situations. And we think over time we're going to see more and more workloads moving onto these environments, primarily because of the economics and the flexibility, ease of expansion, that type of thing. So disaggregation is another trend that we're seeing, which sort of, you might think that this runs counter to what is happening in the SDS space, but that's not necessarily true. So disaggregation, the basic definition there is architectures that allow you to scale servers and compute power completely separately from the storage infrastructure. So hyper-converged, where you have compute and storage services in the same server, is sort of what the flip side of this coin is. And with the disaggregated model, people that really want to be able to more finely adjust the balance between compute and storage prefer this. And we're actually starting to see a lot of the extremely large web scale users who had, over the last 5 to 8 years, were toying with the hyper-converged model, are now starting to think about going back to disaggregation because they feel like it provides more flexibility, particularly at scale, to get that right mix of compute and and storage services in their environments. Now, the one other comment I wanted to make about the trend space is in the cost arena. And, we mentioned the flash performance and how critical that is one of the drivers of deployment, but one of the really interesting things about flash is the total cost of ownership that's really driven by what we call the secondary economic benefits of flash deployment at scale. And let's take a little bit closer look at some of those. So I commented earlier that you buy far fewer devices to meet storage performance requirements. You get to use the data reduction sort of multiplier when you're buying devices, so you end up with a much smaller storage infrastructure. You have lowered power and cooling, less floor space. We talked about that. But some other things that are interesting is because of the much lower latencies with flash, you see significantly higher CPU utilization, which means you get a lot more performance out of each server. And what we've seen from all-flash, migration to all-flash configurations, that companies will typically end up needing somewhere between 5 and 30% fewer x86 servers to drive storage performance. So, x86 servers aren't that expensive. It's sort of interesting, but what really is interesting about that is that when you buy fewer servers, you end up also licensing expensive software products like Oracle, Exchange, SharePoint on far fewer servers. So there are some savings that are associated with that as well. And then on the administration side, so I mentioned earlier this factor that we're seeing storage tuning pretty much drops to zero. Time spent doing that drops to zero when you deploy all flash, just because the flash cup runneth over when it comes to performance in these environments. But there are savings associated also with the software designs in these systems that make things like provisioning easier. They enable non-disruptive expansion and reconfiguration of environments, that type of thing. And then a final consideration is because flash is an electronic rather than a mechanical media, you get significantly higher device-level reliability. So this might not mean that much if you've got smaller configurations, but once you're starting to build out environments that have hundreds of terabytes or even petabytes, and you think about how many hard disk drives that would require and how often you would be replacing failed hard disk drives versus what that looks like in all-flash environments, there are some savings here. And this isn't really getting to availability because, there are dual parity and in some cases triple parity implementations that are available in a lot of these products. So, there's not going to be any downtime associated with a failure, but clearly somebody has to go in and replace failed components when they do fail. So this is another area where some savings can accrue. So I just wanted to close my comments, talk a little bit about the relationship with between plummeting flash costs and how we see flash penetrating into a variety of different kind of workloads. So typically those secondary economic benefits are going to be much higher the more latency sensitive an application is. And that's why we see flash really coming to dominate in the primary arena over the course of the next several years. But flash costs are going to continue to drop, and as they do, that just means that flash can be deployed for more types of workloads, less latency-sensitive workloads. And we actually have started to see this year the introduction of some new all-flash products that are specifically targeted at what have classically been considered secondary storage environments. So we think over time vendors are going to start to go after that space a little bit more, but clearly those are much more capacity and cost-conscious environments. They don't necessarily need the latency benefits of flash, but people tend to be interested in some of the throughput and bandwidth capabilities there, in those configurations. So we do think that we're going to see flash over time not only dominate in the primary arena, but also start to encroach a little bit on the secondary arena. But we don't see them replacing hard disk drives, particularly for some of the coldest secondary application environments. So with that, I'd like to close my comments, and I guess I'll hand it back to Alana.
Thank you, Eric. That was great, and we've had some great questions coming in. First question, early on, stories persisted that SSDs were less reliable than hard drives for archival use. Don't hear that much anymore, so has it been solved, and how?
Yeah, so what's it's kind of interesting. There's a couple of counter trends going on here. So as we've moved from single level cell to multi-level cell and then triple level cell technology, which helps to drop the dollar per gigabyte cost of flash, the flash media itself with each of those changes is actually getting less reliable. But what's happening above that, typically this is done in the flash controllers and in the software layer. There have been a lot of advancements in terms of wear leveling and write minimization against the flash media, and we're seeing a number of vendors now are offering 5-year and some as long as 7-year wear guarantees against their flash media. Now, obviously, all of the flash media in these enterprise class arrays are protected by at least some kind of a dual parity configuration, so when a failure occurs, you're not going to have a problem. But vendors wouldn't be offering 7-year guarantees on their flash media if they didn't feel that they'd solved this problem. And I can't even remember the last time I spoke to a prospective buyer who was concerned about flash endurance at this point. I think this was really more an artifact of, the very early days where a lot of the software management about how writes in particular were laid out on flash, that was very rudimentary back in the 2011, 2012 timeframe, and we've come a long way since then. So they're able to use, triple level cell media and make that media last more than basically the useful life of the array.
Yeah, great point, Eric. Thank you. Another question, when you were talking about the price differences between flash and hard drives, data reduction can also be used on HDDs, so wouldn't the price difference remain?
Well, yeah, so actually this is a point that I've heard this question come up before. Absolutely, data reduction can be used on HDDs, but it can't be used on HDDs for latency-sensitive environments. And that's really what the key here is that flash, because of its latency, has enabled the use of inline data reduction without undue performance impacts on the application. And that's what makes it so much more interesting than HDDs in these environments, is you can get the benefit of that. There's actually benefits to, you can increase performance because you're writing less data. You can improve the endurance of the underlying flash media, again, because you're writing less data when you're doing inline data reduction. So, it's the fact that flash has enabled the use of this in an inline manner with performance-sensitive apps that's the key differentiator. Data reduction on HDDs will clearly be used for less latency-sensitive secondary environments, and it's very popular in the backup arena today.
Great, thank you. And last question, on the secondary economic benefits of flash deployments at scale, how do those differ from an all-flash versus hybrid flash configuration?
So, the comparison that I gave on that slide is related primarily to coming from an all HDD-based environment to an all-flash. So a hybrid product will get you part of the way there. So the benefits won't, or the differential won't be as great if you're moving from a hybrid to an all-flash. But those benefits still exist, and again, they're going to be more prevalent the more latency sensitive a particular application is. But if you're already running some kind of a flash optimized hybrid, then you're already part of the way towards achieving some of those benefits. But you're not going to get all the way there until you move to an all-flash configuration.
Great. Thank you, Eric. Well, that was very insightful. Now I'd like to move on to Brent and really talk about real-world performance. You're in the trenches, Brent, and I think the audience would love to hear about your experience.
Sure. Hi, everybody. So a little bit about Northern Backup. Northern Backup, we're a managed services provider in Calgary, Alberta. We've been starting our kind of private cloud, hosted cloud, dedicated cloud practices for about 6 years. We're not huge, but we're definitely confident in our size and our flexibility to respond to our customers' needs. in kind of our challenges that we've faced in being a managed services provider, I can talk back to some things that Eric mentioned in regards to the evolution of storage since 2011. So we started with our standard storage practice using storage area networks, fiber channel connected, then moving to an iSCSI environment, then moving into a hybrid flash SAN with tiered storage, and et cetera, et cetera. So we started down the software-defined storage journey about 12 months ago with our first Nexenta storage. And then we followed that up recently with a all-flash SanDisk-powered Nexenta storage array as well. So what I'm going to do here is I'm going to go into some technical performance kind of details that we did in our Nexenta versus Nexenta all-flash testing. So we ran the environment on unloaded systems. These are Windows 2012 R2 virtual machines. We used a tool from Microsoft called disk speed, and we ran the disk speed with a command that gave it a mimicking SQL Server workload. So we were looking at 8K block size, random read writes, disabled all the software caching, everything like that. Again, we're running on VMware 6 as our hypervisor. We have a 10 gig network internally, and then we kind of did some averaging across each host. Also, for kind of some legacy and some other examples as well, we went and picked 2 virtual machines that you can purchase from Amazon and Microsoft to run the same tests on. And then we also had a legacy Apache Hus SAN that was a 10K SAS RAID group. The first test that we performed was our input-output operations per second. So the yellow line here gives us our baseline of where our current performance was with our Nexenta, and we were incredibly happy with that. We were looking at almost doing 10,000 IOPS per second in this random 8 kilobyte block size total. We were astonished and very, very happy with that performance. Once we rolled out the all-flash Nexenta array, we saw those almost increase like 2 or 3 times. It was a great kind of feature that we can use to densify our storage footprint, as well as pass along some of these faster storage response times to our customers. One thing that also comes with a lot of IOPS is people don't think about the transaction time that it takes to complete. So if we take a look at our average disk latency, so this is the average disk latency while these transactions were going on. So you can see that we're still under 10 milliseconds on our current Nexenta, but we dropped down to a 2.1 when we were doing those loads. So we were, again, very, very happy with that performance. That really equates to kind of having a quick user response, whether it be in a VDI environment or an RDS, or a certain application running and querying a report, or a poorly written query that needs to query a database quite a bit. That very, very low latency access speeds up those things tremendously. The last thing we looked at was our processed megabytes per second. So this is the amount of data that's actually moving through the buses to the storage array from the virtual machine. So you can equate this to maybe a SharePoint environment where you're going to be uploading a very large document, maybe your SQL Server backups being written off, or maybe large blob analytics kind of information. And again, with the all-flash, we were faster than our current Nexenta, which was quite a bit faster than where our legacy storage, as well as some of the Amazon and Microsoft cloud providers that are out there. The other kind of secondary things that we found were the speed that we're able to provide these systems to our customers was unbelievable. So we had certain people with SAP applications, SAP Business One, systems where inventory reports and stuff like that would take a very long time to return back to the user. Rather than needing to re-architect that report, we were able to go and place that workload on the flash array, and we noticed a dramatic increase in that report speed, which was excellent for us to be able to provide without really needing to dig into going back to the application vendor and saying you need to rewrite your report or increase it. Some other very interesting facts that came out of our full investigation. So we have two clusters that we put head-to-head here. One is an HP front-end cluster, so there's two HP DL380s that run the Nexenta Store software. There is a HP disk array attached behind that running 4 terabyte SAS disks. And we did the power numbers and kind of crunched the numbers, and we were looking at about 15 watts per usable terabyte of storage is what we saw. And our rack footprint was quite a bit bigger than where we were with the flash. So we were almost looking at only getting 13 terabytes per U of rack space. If we take that to the InfiniFlash with the two same HP nodes providing the front end, you can see that our rack footprint as well as our watts per terabyte of usable storage is just dramatically cut in half. So we had tons of rack space savings, tons of power savings by doing this. We're able to fit so much more in such a dense area, which is very valid, a very good thing for us because we want to reduce our rack footprint as much as possible to reduce our hosting costs.
So Brent, let me ask you, you know, this comment I made about storage tuning, time spent storage tuning goes to 0. Did you see any kind of a similar change when you made the move to all flash?
Sorry, pardon me, you cut out there for a second.
Yeah, so I was just asking if you saw any of the savings on the storage tuning side when you moved to an all-flash configuration.
Oh, most definitely. So in your example, and the good question, you know, application developers or development group inside of an organization would bring a server that used to be in test dev into production. They wouldn't notify the storage admins, and then the application wouldn't be performing to the needs of the end users because it was sitting on the wrong LUN. With the overhead and the speed of the flash, we're able to just provide an all-flash experience for all of those workloads. So we don't really need to have that storage tuning workflows. But that pretty much sums up my little set of stuff, I guess.
Great, thank you, Brent. And there are some questions that came in. Have you noticed any improvements in non-Windows virtual machines or other workloads?
Yeah, so particularly some Oracle databases have dramatically also increased. We have some Linux web servers that are able to serve many more pages per second for the customers. So yeah, we've definitely seen increases across the board, not just in Windows SQL workloads.
Great. And how about the CPU performance when you moved to all flash?
So the CPU performance, what we've been able to do is we've been able to have more virtual machines running per host. So we've seen a density increase in the number of virtual machines we're running on each host. And in terms of the NexentaStor hosts that are running the storage, we've seen a decrease in those CPU operations compared to how much storage is available. There's less compute needed to be done by the NexentaStor because the storage is providing such a fast interface. Okay,
great. And did you just use compression with InfiniFlash, or were you able to use deduplication?
You know, if you, I can take that question offline. I don't have that on the top of my head. I believe we're using a compression algorithm. I'm not sure if deduplication is enabled on the array.
Okay, all right, thanks. And have there been any unexpected challenges, you know, when moving to all flash?
No, just really being shocked at how much it can consume as a workload. It really surprised us with its ability to perform.
Great. Well, we'd love to hear that. Well, thank you so much, Brent. That was really insightful. And if there are any other questions for Eric or Brent, don't be shy. Continue to submit them. But I thought it would be good for us to now kind of transition to the technology behind this And with that, I'll hand it over to Mike to talk a little bit more about Nexenta and NexentaStor.
Thanks. Well, I thought after Brent went through it and pointed out all the great features and the benefits he's got, it's kind of nice to know what he's using on the back end, I think, there, and how he's utilizing. We'll dig in a little bit on the hardware with the InfiniFlash in a moment, but from the software side, what we're utilizing is the NexentaStor package. So it is Nexenta's unified file and block scale-up solution. Really what we do with that is provide a no vendor lock-in solution on it is what we really aim at. So you've got a lot of different choices, whether it's from the head nodes, then into the JBOD even. As Brent was saying, he had started with a hybrid solution and then moved into the InfiniFlash for his high-performance solution. So you really have that flexibility across, still a single interface, though, to manage them, regardless of the workload. So on some workloads where we may be looking at primarily virtualization, maybe you're looking at NFS on it. If you're looking at more of a block solution for database backend, that capability is there, all while adding in that enterprise feature set that you would expect out of an array for your current data center. There's some things that are just table stakes nowadays with storage solutions, things like snapshots and replication. And those have to be there, and they have to be simple. And that's really what we try to make with software-defined storage from Nexenta, with NexentaStor's ability to make it simple, make it easy for the admin, as well as kind of saving on some of that processing time that got brought up earlier. With that, making sure that you're certified, you're integrated in with all of the partner ecosystem, from VMware through OpenStack solutions, and then, of course, utilizing any of that hardware from the SanDisk on the back end, and then if you choose that the HP or Supermicro or Dell or whoever you're looking at, we have reference architectures built around that. Building on that, the software is really just deployed bare metal on x86 servers. It is the full storage operating system, we would say, and provides both file and block on it. File from all the way from a 10 gig, even some solutions faster than that, on NFS, SMB, at this point with 2.1.3.0 when you're looking at it for Hyper-V solutions, as well as utilizing the latest block solutions from 8 gig and 16 gig fiber channel, and then of course iSCSI as well on block. With that, we presented out those head nodes as either a single or dual heads in an active-active cluster, meaning we can present pools off of both of those heads. One of the questions earlier was about CPU performance. One of the nice things about having that active-active cluster is the ability to spread the workload across. And even though you may be hitting the same InfiniFlash array on the back end, if they're different pools, we can present out some of that and utilize the CPU on each one of those head nodes, so you get double the power when you're using it. Obviously, of course, for redundancy as well, if you need to fail from one to the other, it makes it a lot easier on recovery time. Doing this, we can scale anywhere from small solutions up into the multi-petabyte range. And as we talk about it with the InfiniFlash, with the ability to do a half a petabyte in that 3U, we can really get a lot of that density. And that's that transition that a lot of our customers are seeing today, along with snapshots, clones. That stuff that says table stakes on there. But it's not just table stakes for us, because we're going to make sure that you've got heavy data integrity on the back end. We've got 256-bit checksuming across the entire file system, as well as unlimited snapshot clones because of the way our file system works. You've got protection then on your data from the software side. And then on the disk side, if you have failures, we of course provide things like RAID protection of a disk failure or an chip failure in the event of the InfiniFlash. So we really give you a lot of different choices on how you want to be able to utilize that. With replication, of course, from one site to another if you need it. And then the question came up about data reduction. We do have that data reduction in place for things like LC4 compression and the ability to get the most out of your InfiniFlash. With that, really, I mean, that's really the software side of it, but we want to make sure we've got plenty of time to talk on what this hardware that Brent has proclaimed about. So I don't want to take too much time on that software side, and I'll hand it over to Steve here.
Thank you. And InfiniFlash, really we were able to start with a clean piece of paper here. So instead of trying to make the NAND look like hard drives and keep to an SSD form factor, we were able to really think about how would we start this starting from scratch, and that's really about this the flash module, 8 terabytes on a card. This card is wafer thin, so it presents an almost unobstructed airflow through the box, which contributes further to the low power requirements of the box. We specify it at 450 watts, but quite frankly, we've never actually managed to get it to draw that much power. Extremely low power. Everybody's talked about the density. We've seen customers go from 6 racks to 6 U's for a petabyte. And of course, the reliability of flash, and of course the native performance. So what we're bringing here is this extreme density to go along with the performance, being able to bring not only the performance, the reliability, the density, the power savings, all of that together, combined with the being able to put this into a realization of the lowest cost form factor. And Eric mentioned that some of these systems are going out at $1 per gigabyte with including data reduction techniques. We're actually closer to $1 a gigabyte before data reduction techniques. So it really does make the all flash, or certainly mostly flash data center really economically viable today, not just in the future. So with that.
Great. Well, thank you so much, Steve, Eric, Mike, Brent. This is great. Just to circle back quickly on the question about compression and dedupe, Brent confirmed that they were just using compression for that. And if you do have any questions, we have some more time. Oh, we have another question that did come in. So it can go beyond 2-node active cluster for SAN and NAS, 4, 8, etc.
So I'll jump in on that one, Elena. So NexentaStor is set as a scale-up solution, and it does set at 1 or 2 nodes on NexentaStor. We also do have a scale-out solution that can go to tens and hundreds of nodes. That is a block and object solution with edge. That would, if you need to expand back past that and want the CPU of it, that can still, of course, use the InfiniFlash behind it as well.
Okay, thank you. Well, that concludes our presentation for today.
Lana, I'd actually like to ask Steve a question, if you don't mind. So, Steve, you talked a little bit about the custom flash modules that you're using instead of SSDs in the InfiniFlash product. And, I think it's interesting that some of the other product introductions we've seen from other vendors that are targeted at the same space that InfiniFlash is, kind of the big data workloads, that type of thing, have also chosen to take that approach and are not using SSDs. And we're seeing more systems leverage this kind of a design. And you commented on a couple of the advantages that you feel that the custom flash modules give you over SSDs. Can you just give us a quick rundown, sort of in the area of, I would assume it's going to be storage density, cost, some other things of that nature, what you see the benefits of using custom flash modules over SSDs, off-the-shelf SSDs, for this kind of a configuration?
Sure. You have to remember that SSDs look like hard drives because it was easier for system manufacturers to plug them in sort of as a direct replacement for hard drives, for spinning hard drives. But that entails a lot of compromises in essentially folding up the NAND into mechanical packaging that holds the heat in, which doesn't do reliability any good. It certainly doesn't help with the cost perspective. So being able to lay these things out on a very flat, very thin card also reduces the cost. It improves reliability, lowers the power. It also enables us to add in things like power capacitors, so that we can do power fail safe write modes. So that we can, if you do suffer a power failure, you're going to be able to write out your cache to non-volatile memory. So just about everything gets better.
Yeah, so just an interesting side note, as we look at the revenue contribution in the all-flash array space from SSD-based designs versus that from custom flash module-based designs, we are seeing the custom flash module-based design contribution growing over time. It should be, for 2016, it'll probably be in the 20 to 21% range, revenue contribution growing to about 26-27% by 2017. So we are seeing more vendors who I'm assuming are buying into the same benefits that you just mentioned in creating systems around these custom flash modules.
Right, and in addition, of course, we own the fab, so it's we kind of have that vertically integrated benefit to add into this.
Yeah, you're sort of unique in that sense relative to most of the other folks that are shipping all flash arrays.
Exactly.
Great. Well, thank you again, everyone. We will have this presentation available on demand. If there are any questions that come up, or for those watching on demand, you can always leave them in the feedback, and we'll certainly keep an eye on that and get back to you. But just want to thank everyone again for attending on the phone and on the call as well, Mike, Brent, Eric, and Steve. And until next time, make it a great day.